Hello everybody, welcome to acid-base titration. Okay, the reaction we're looking at today is HCl plus NaOH going to H2O liquid plus NaCl aqueous. Now this reaction goes 100% because we're dealing with a strong acid and a strong base. Okay, so in this situation, the molarity of the acid times the volume of the acid will give you moles of acid, which at the equivalency point will equal our moles of base, which will equal the molarity of the base times the volume of the base. So in part one of this experiment, we're going to be determining the molarity of the sodium hydroxide solution. Sodium hydroxide comes to us as a solid, but it is hydrophilic, which means it's water-loving. Since it is water-loving, it will absorb water from the atmosphere as soon as we open the bottle. So when you weigh sodium hydroxide, you really don't know how much sodium hydroxide you're getting and how much water. So we always have to titrate to determine the concentration of the sodium hydroxide solution. So what this comes down to is the molarity of NaOH is going to equal the molarity of the acid times the volume of the acid, you can use it in milliliters, divided by the volume of base that we're going to add. Okay? So we're going to do 3 titration runs to determine the volume of base added in those 3 runs, average them together, and then do this calculation. And then we're going to use that sodium hydroxide that we have determined the molarity of to determine the molarity of an unknown HCl solution. So let's get to work. Okay guys, this is a burette. I'll get up here close so that you can see. Now this burette is filled with sodium hydroxide. And it's a 2-deliver instrument, so we read from the top down, okay? So if we look at this, our starting volume of NaOH is 0.00. Now in the Erlenmeyer flask, I have my HCl solution, and we're gonna add an indicator to each one, okay? Now the indicator is clear when it's in HCl, and it will be pink when we're in NaOH. I'm grabbing my data table so that I can write down the data just like you guys are going to do. Okay. All right. Now let me flip to the right page. Acid-base titration. All right, now I'm going to lift up my burette. I'm going to put my Erlenmeyer flask in there. I'm going to lower my burette down until the tip is inside the Erlenmeyer flask. Okay? So now we're going to titrate. So what that means is I'm going to be adding the base into the acid solution, okay? And I want to kind of swirl as this happens, and what I'm looking for is the appearance of pink. So right now, no pink yet. I'm seeing some faint pink just where the base is coming in, okay? Notice how the pink is getting stronger. So I'm going to start swirling. See how the pink is showing up in there? It's getting more persistent. As it gets more persistent, I want to slow down the rate at which I'm adding the base, because I want to hit just that point where it starts where it turns pink and it stays pink. If I can swirl it and make the pink go away, I'm not at the end point. Okay, now this is where a little patience comes in handy. Okay, now it's turned a pale pink and it faded away pretty quickly. So I know I'm probably within a couple of drops. So I'm just going to add a couple of drops. Okay, we're real close. Ah, nice pale pink, and it's staying. So now we're going to go up and read our burette. Okay, to read the burette, I'm going to hold a piece of paper behind where the meniscus is, okay, so that you can read it. Now I'm going to read it myself. I can't hold the camera and read and do it all at one time. I'm getting 23.00 for this first run. Okay, so I'm done with that flask. I'm going to set it to the side, and now I'm going to do my second. Now, I know that I have 50 milliliters in here, and I'm starting out at 23.00, so that should be no more than 46. So I should be good to just run with the burette as it stands. I'm going to let it run down to 45 very quickly, and then I will slow down for that last milliliter. Okay, I'm down to 33. Oh, okay, that real close. Okay, couple of drops. There we go. And this time I'm getting a final reading of 44.00. Okay, now I'm going to have to refill the burette before I go on, because I have less than 10 milliliters left in the burette, and we know it's going to take 20 something milliliters to get to where we want to go. So I'm going to refill the burette, get it back up to the 0 line. Okay, and we move on to our third one. Again, I want the tip of the burette in. My initial burette reading is 0.00, and I'm going to go down very rapidly to 20 milliliters. And after 20 milliliters, I'll start going slow. See how the pink is getting more persistent? Means it's definitely time for me to slow down. Now I'm just going to let it drop. Okay, probably just a couple of drops. The paler the pink color we can get to persist, the better. We're close, real close. Okay, that pink color is persisting. We are there. So our final burette reading this time is 21.30. That first one may be an anomaly, but that's the way science is, okay? So now we want to look at doing our unknown. Now, instead of making you watch me do 3 more titrations, I've already done the unknown. And here's our data, okay? The initial burette reading on run 1 was 0. The final burette reading was 16.25. For the second one, we started at 16.25 and went to 32.20. And for the third one, we started at 32.20 and went to 48.30. So you can subtract, get your volume added, get your average volume added, and calculate the average volume and your molarity of your acid. The actual molarity of your acid is 0.075 molar. So see how close you got. Okay guys, good luck. Remember, include all your data.